Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 6 Electromagnetic Induction. Today again we are going to continue the Faraday and Henry experiments part 2. In the previous class we studied the first experiment and which is called coil and magnet experiment or current induced by magnet. So there are totally 3 series of experiments which were done by the scientists Faraday and Henry. So these experiments are called Faraday and Henry experiments. We studied the first experiment in the previous class and today we can study the remaining 2 experiments. Yes, the experiments of Faraday and Henry part 2. Today we can study experiment 2 and 3. Experiment 2 is coil and coil experiment or which is also called as current induced by a current. Remember in experiment 1 we considered coil and magnet. But here there is no magnet. Instead of magnet we are going to consider 2 coils. Using 2 coils how to induce or how to generate current that we can study in experiment 2. In experiment 2 we are going to consider 2 coils. You can observe the picture. There are 2 coils C1 and C2. How many coils are there here? 2 coils. The first coil is denoted by C1 and the second coil is denoted by C2. C1 coil is connected to galvanometer. This is what galvanometer. Galvanometer is a device which gives the presence of current. Right? Then the second coil C2 is connected to battery. C1 is connected to galvanometer. C2 is connected to battery. So this is the construction of the experiment. What we are going to consider in experiment 2? We considered 2 coils. These 2 coils are having n number of turns. The first coil is C1 which is connected to galvanometer and this galvanometer shows deflection and that gives presence of current. Then coil C2 is connected to battery and from the battery we will get electric current. Right? Now you can observe. In the figure, the bar magnet is replaced by a second coil C2 which is connected to a battery. See here, instead of using bar magnet, I am going to use one more coil and that coil is connected to battery. When the second coil is connected to battery, then the steady current in the coil C2 that produces a steady magnetic field. Observe this diagram here. The second coil is connected to battery. When the battery is switched on, then the electric current starts to flow in the second coil. When electric current is flowing, then we know that electric current is surrounded by both electric field as well as magnetic field. Anyhow, now we can consider only magnetic field. The second coil is completely surrounded by magnetic field. But here, when the battery is switched on, for example, I am going to consider 12 volt battery. Right? So, when voltage is constant, then electric current in the second coil is also steady or it is constant. So, the magnetic field surrounded by the second coil is also constant. Is it clear? We have steady current in coil C2 and it produces steady magnetic field. Now, as coil C2 is moved towards the coil C1, then the galvanometer shows deflection. See here, instead of magnet, we considered coil C2 connected to battery where the current is flowing, so the magnetic field is present, but it is constant. And we know that when a magnetic field changes, then only current is produced in the coil. So what we are doing, instead of moving or instead of taking bar magnet, I am going to move the coil C2. When coil C2 is moving towards coil C1, Already this C2 is surrounded by magnetic field. When it is moving towards the first coil, then magnetic field changes. Because the coil is moving. When coil is moving, then magnetic field changes. When magnetic field changes, then electric current is produced in the first coil, so that galvanometer shows deflection. When the galvanometer shows a deflection, that indicates yes, the current is produced in the first coil. Now the question arises, when magnetic field surrounded by coil C2 changes, then why current is produced in the first coil? Yes, see here, the first coil, it is a conductor having n number of turns. It is having large number of charges. All the charges are at rest because there is no force exerted on the charge. So all the charges are at rest. When the second coil is moving towards the first coil, magnetic field changes. It will exert force on the charge so that charge starts to move and the current is produced. Galvanometer shows deflection. So what it indicates? This indicates that electric current is induced in the coil C1. Is it clear? Then come to the second point. When coil C2 or when a second coil is moved away from the first coil, then galvanometer shows again deflection, but this time we will get deflection in the opposite direction. You can observe this diagram. When you are going to take the second coil away from first coil, magnetic field decreases. So the force exerted on the charges in the first coil also decreases. So these charges starts to move away from coil C2. So current is produced, but where? In the opposite direction, so that galvanometer shows deflection in the opposite direction. Suppose if the second coil is at rest, if I am going to hold that second coil at stationary, whether the current is produced in the first coil? No, current is not produced because we can generate electric current only when magnetic field changes. Here, magnetic field changes only when coil is moving. So that's why when second coil is at rest, then we cannot produce any electric current in the first coil. Then one more point. Suppose instead of second coil, if I am going to move the first coil towards the second coil, is it possible to produce electric current? Yes, it is possible. Instead of second coil, if I am going to move the first coil towards the second coil, anyhow magnetic field with respect to the first coil changes. Induced EMF takes place. That means electric current is produced and galvanometer shows deflection. Either you can move first coil or you can move second coil. We can easily produce electric current because magnetic field is changing. If both the coils are at rest, then we cannot produce electric current. Observe the second point. The deflection lasts as long as coil C2 is in motion. That means electric current is present in the first coil. We can generate electric current in the first coil until the coil C2 is in motion. If second coil come to rest, then electric current decreases and it reaches 0. The current is present in the first coil until the coil C2 is in motion. Then third point, when the coil C2 is held fixed and C1 is moved, instead of second coil, if I am going to move first coil, again the same effects are observed because magnetic field with respect to first coil changes. The next point, the above two experiments involved relative motion between magnet and a coil and between two coils respectively. Observe, in the first experiment we considered magnet and coil movement, relative motion between magnet and coil. But now in the second experiment we considered movement of two coils, first coil or second coil. So here in the first two experiments we considered relative motion between magnet and coil or coil and coil respectively. Then what you came to know from the second experiment? In the second experiment, remember the points. We replaced magnet by a coil which is connected to battery. So electric current is produced in the second coil. That current is surrounded by magnetic field. When that magnetic field changes, then we can produce electric current in the first coil. That magnetic field we can change only by the movement of the coils. Either you can move first coil or you can move second coil. When the coils are in a relative motion, then magnetic field changes, electric current is generated, and that current is present in the first coil until the coil is in motion. If they are at rest, then there is no current. Is it clear? So this is all about experiment 2. So from this experiment, we know that, or we came to know that whenever magnetic field changes, then only induced EMF takes place. That means whenever magnetic field changes, electric current is induced in the closed coil. So this is all about experiment 2, and which is called current induced by current. Just by using current, we are going to produce current in the first coil. Now we can study about third experiment, and that is coil and coil experiment, which is also called as current induced by changing current. In the first two experiments, we considered relative motion, but here in the third experiment, there is no movement of the coil. Without any relative motion, we are going to generate electric current. How to generate electric current? Let us study. Yes, in experiment 3, again I am going to consider two coils. The first coil is C1 and the second coil is C2. First coil is connected to galvanometer. Second coil is connected to battery and tap key. K indicates a tap key. Is it clear? So what is the construction of experiment 3? We considered two coils, C1 and C2. The first coil is connected to galvanometer. Second coil is connected to battery as well as a tap key. What is the use of this tap key? You can observe this picture here. This is a tap key. When this tap key is pressed, current will flow. When this tap key is released, current will not flow because the connection will be breakdown. Is it clear? When the tap key is pressed, current will flow through the coil. When the tap key is released, then there is no electric current. This point you can remember in experiment 3. The figure shows two coils C1 and C2 which are held stationary. They are not moving. There is no relative motion. Both the coils are at rest. Right? Then the coil C1 is connected to galvanometer which shows the presence of current. Similarly, coil C2 is connected to battery through a tapping key K. We considered battery as well as a tap key. Right? Then it is observed that the galvanometer shows a momentary deflection when the tapping key K is pressed. Observe what happens. The battery is connected to second coil. When the battery is switched on, the current will start to flow throughout the coil C2. This current will flow only when the circuit is closed circuit. So to make it complete circuit, we have to close the key. When the key is closed, then current will flow. When the key is open, current will not flow. Now observe, I am going to take a 12-volt battery, right? Now battery is switched on, but the key is open. When the key is open, the current will not flow. So now I am going to press that key. Here, when I close that key, the current starts to flow throughout the coil C2. How much current will flow? For example, if there is a 12-volt battery, I will get 10 ampere current. Let us imagine we considered a 12-volt battery. Through that, I will get 10 ampere current. When I press that tap key, suddenly 10 ampere current will not flow. Initially the current is 1 ampere, 2 ampere, 5 ampere, 9 ampere. At last we will get 10 ampere. So here it indicates when we press the tap key, current go on increases. At last it reaches 10 ampere. When the current is increasing, current is surrounded by magnetic field. When current is increasing, magnetic field also increases. Magnetic field is increased. That means change in the magnetic field takes place. Because of changing magnetic field, induced EMF takes place or electric current is produced in the first coil, so that galvanometer shows deflection. Is it clear? Similarly, when I am going to release that tap key, when I open this tap key, then suddenly the current will not become 0. Here the maximum current is 10 ampere. When I release the key, 10 ampere current go on decreases, just like 10, 9, 7, 5, 2, 1, 0. When we release a tap key, current go on decreases, magnetic field is decreasing. That means magnetic field changes. So current is produced in the first coil. Galvanometer shows again deflection, but it is in the opposite direction. So here in experiment 3, we are not going to move any coil. Instead of the relative motion, just we are using tap key, which changes the current. When current is changed, magnetic field also changes, so that current is produced in the first coil. Right? Now you can observe, when the key is released, a momentary deflection is observed again, but in the opposite direction. Only momentary deflection. See here, when I am going to release the tap key, the maximum current is initially 10 ampere. When I release the tap key, the current go on decreases. It decreases from 10 ampere to 0 ampere. 10, 9, 8, 7, 5, 2, 1, 0. How much time is taken to come to 0? It takes a fraction of seconds. So that when current is decreased from 10 ampere to 0 ampere, in that fraction of second, only the current is produced. So it shows just a deflection, again it come back to 0. Galvanometer shows deflection, immediately it comes to 0. Means only for a fraction of seconds, current is induced in the first coil. Is it clear? When the tap key is pressed, current is increased from 0 ampere to 10 ampere. How much time is taken to increase the current? Just few seconds. So that few seconds, only magnetic field changes, so the current is produced. So when the tap key is pressed or released, only momentary deflection is observed in the galvanometer. When it is pressed, galvanometer shows deflection on one side. When it is released, galvanometer shows deflection in the opposite direction. Observe the first point. The pointer in the galvanometer returns to 0 immediately if key is pressed continuously. When you are going to press the key continuously, current remains constant. Magnetic field surrounded by that electric current remains constant. So there is no induced EMF. There is no deflection in the galvanometer. Second point, it is also observed that the deflection increases dramatically when an iron rod is inserted into the coils along their axis. If you want to increase electric current in the first coil, just we can use one iron rod, and this iron rod is inserted into these coils along the axis. When we insert this iron rod, this is again a conductor, it contains large number of charges. So by using this iron rod, easily we can increase the current. So this is all about third experiment. So remember, in the third experiment, we are using two coils, and the second coil is connected to battery as well as a tap key. When a tap key is pressed, current increases. When a tap key is released, current decreases. Only for a few seconds the current is produced in the coil. So galvanometer shows deflection, immediately it comes to 0. If you want to increase the current dramatically, we have to use iron rod between the coils so that the electric current is increased. So this is all about third experiment. We studied 3 experiments. The first one is coil and magnet experiment. Second one, coil and coil experiment. Third one is coil and coil experiment. But here we used tap key. Then what is the conclusion from the above experiments? Observe the conclusions. This is very important. The first point, Faraday's experiments shows that an electric current is produced in the wire loop, means in the closed circuit, only when magnetic field at the loop is changing. This is very important. Faraday's experiments that shows electric current is produced in the wire loop only when magnetic field at the loop is changing. Then second conclusion, a changing magnetic field that produces an electric field. When magnetic field changes, then it will produce electric field. Observe this point. An electric field produced in this way is called an induced electric field. When you are going to produce electric field in this way means just by changing magnetic field, we induced electric field. So we can call it as induced electric field. So this phenomena is called electromagnetic induction. Yes, how to define electromagnetic induction? The phenomenon in which electric current is generated by changing magnetic field. Just by changing magnetic field, we are going to produce electric current. So we can call that phenomena as electromagnetic induction. So this is all about the Faraday and Henry 3 experiments and the conclusions. Using these experiments, so later you are going to study about Faraday's laws. The conclusions of these experiments are itself the laws of Faraday or Faraday's laws of EMI. So that we can study in the next session.